Hello, this video is the continuation of the Cloud Native Ninja series. So far in this series, we have seen how to build an application which uses Dapr or distributed application runtime and how to use KEDA or Kubernetes based event driven auto scaling to scale the number of consumers. I've used the PowerShell script which allows me to deploy different components of the application like the autoscaler, then the Dapr configuration, the producer for TechTalks and the consumer for the TechTalks application. It would be nice if we can use one single command which allows us to deploy the whole application in one go instead of applying these different Kubernetes files one by one. That is where today's topic of this video is. We are going to use Helm, which is a package manager for Kubernetes, which allows us to package the different dependencies for an application, and it simplifies the process of deploying a complex application onto a Kubernetes cluster. We can think of a package manager as similar to something what the operating systems offer. Like on Windows, we have the Chocolatey package manager, or the recent versions of Windows, it offers Winget. Similarly, on Mac, we have the Homebrew package manager, which allows us to download packages, to upgrade, install the packages, and to remove packages or uninstall them when we don't require those packages. We can do the same thing with Helm for the Kubernetes. Let's head over to the Helm homepage and see what Helm has to offer. Here we see that Helm has graduated in terms of the CNC of projects, and it is maintained by the Helm community. It gives us this installation guide, or it helps us to define, install, and upgrade most complex applications by using things like simple sharing of the charts. Chart is a mechanism in Helm by which it packages the application, and then it uses releases as a mechanism to version those packages. We can also do rollbacks to a previous version using the Helm package manager. To get started, if we don't have Helm installed, we can follow the installation guide here, and I've used the Homebrew package manager to install Helm. If you're on Windows, you can use Chocolatey or Scoop, and for other operating system, similar package management support is provided. Once we have Helm installed, let's head over to the terminal and we can see what are the different commands which are supported by Helm. So if we do helm-h, it will give us the list of the top level commands, and like any other CLI tool or the command line tool, we will get to know what are the different options that we need to supply, or what are the different parameters we need to supply for this command. So if you look at the available commands, we have the commands for completion, creation, dependency management, environment, history, install, to lint, list, to package the application or directory as an archive, and various other commands. So let's go back and look at our own application and see how we can use Helm to package this. Now, if you look at my application for the TechTalks producer or the TechTalks itself, under the KEDA folder, we have this specific folders for autoscaled consumer, which is the configuration for KEDA, so that our consumer can autoscale based on the number of events or number of messages in the Kubernetes or in the RabbitMQ cluster. Then we have a set of configurations for Dapr, which is used to configure the PubSub mechanism or PubSub component, which is used by the producer and consumer to communicate with one another. Once we have the autoscaled consumer and the Dapr configurations done, we also have the TechTalks Consumer deployment, which is using those configurations, and then we also have the producer deployment and the service. Let's get started with Helm by taking these components for our application and see how Helm can help us to package that. I'm going to create a directory called as TechTalks Helm chart here under my Cloud Native Ninja directory, and I'm going to change into that directory. Once I'm inside that, I'm going to run this command which is used to create a package, and the command is helm create, and I can say TechTalks. And if we list the contents here, we see that it has created a folder called as TechTalk, and then let's do ls with tree equal to depth of 2. We see that it has created chart.yaml, then a folder for charts, a templates folder, and values.yaml. That is a default kind of structure which is created by Helm when we run the helm create command. Let's head over to Visual Studio and look at the contents of this. Under the charts, currently we don't have anything. Under the top level folder, which is the Helm charts, we have Helm ignore, which is similar to git ignore, and it has different folders or files which needs to be ignored during the Helm package creation. Then we have chart.yaml, which is a basic information about the chart itself, containing the API version as v2, name of the chart, and a description. Here we can update the description to say that Helm chart for Kubernetes deployment of TechTalks application. And then we have other properties here to specify that this is a type of application. We also have type as library. Application is the one which is getting deployed. Library is used for a reusable component. Then there is the chart version, which is specific to the chart itself, and we also have the application version. So let's start with application version as 1.1.0, and then we have the values.yaml file. So we'll come to values.yaml file little later. For now, we can see that it has got values like the replica count as 1, image as it has an image tag, and it has the repository as nginx and pull policy if not present. We are not using nginx image as of now or in this particular video, so I don't need some of these values, like the image pull secrets are not required for me. I don't need the service account, pod annotations, and all those things. So except for the replica count, I'm going to delete all those things which are not required right now. And if we go under the templates, we can see there are a set of tests which are created, and it goes and tests that we are able to connect to the TechTalks. It creates TechTalks.fullname. It creates a pod and it tries to go and access that pod. I don't really need this. There is also the helpers, which is like a helper utility, and it contains again some definitions for the useful methods for TechTalks name, full name, and the chart labels, and some common labels which are specified here, like the app version and the release version. Same way for the selector, there are some labels. So we will use this a little later in the demo. And then we have the deployment.yaml. If you look at the deployment.yaml, it has these curly brackets, and it has these things which says include.fullname. Then it has things like with values and pod annotations. Then it does this to YAML. So these are like the template engine which is supported by Helm charts or Helm, and we can specify these reusable components, and we can specify things like indentation, by means of which we can reuse things like the labels. We can use things like pull secrets and image pull secrets, all these things which are specified as reusable values. So think of the values.yaml as a file which stores information which can change across different environments. And then we have the definition or the template for different types of Kubernetes objects. Based on whatever value we supply at the Helm install command or Helm upgrade command, those get merged, and the actual values, they get replaced as part of these templates. So I can use this one for deploying. And same way there is ingress, service, service account, all these things. But if we look at the structure of our application TechTalks, it has got two different services, the TechTalks Producer and TechTalks Consumer. Producer has got a service and a deployment. Consumer has just the deployment. And then we have these dependent sort of objects for the Kubernetes. So instead of using this pre-built or pre-generated files, what I'm going to do is I'm going to delete all this, and I'm going to use the files which are relevant for the TechTalks application. So I don't need any of these files like the ingress, HPA. I'm going to delete all those. Now whatever files I need for the TechTalks application, I can put them under this templates file. I can have them as individual files, or I can group them as folders. That's the good part or best part of Helm template engine. So let me go and copy these 4 folders which are specific to the TechTalks application: the autoscale consumer, Dapr components, TechTalks consumer, and the TechTalks producer. I'm going to copy the contents of this and put them inside the templates folder. With that, we now have the template ready for deploying the application as a Helm chart. So without making any changes for the time being, let's go and create a chart and see how does it work. To package the application, I need to run this command helm package TechTalk. And here we can see that it has successfully created a chart and saved it to this particular location with the zip file or as an archive and named it as TechTalks-0.1.0 TGZ. So this 0.1.0 is the chart version. That is what we specified in our chart.yaml, and that is what is being used by this package manager when it creates the chart. Now let's go and deploy this onto our Kubernetes cluster. One of the prerequisites for Helm is to have the kube context set properly and pointing to the right Kubernetes cluster. Once we have the kube context set, we can use the helm install command and we can give a name like TechTalk, and then we can specify there are two ways in which we can deploy the Helm chart. One is by specifying the contents of the folder like TechTalk here. The other thing is to use the package, which is the zip file or the archive file here. So I'm going to use that approach and use the TechTalk 0.1.0.tgz as the package which is generated. Let's apply this. And we see here that there is some things in the nodes.txt which is trying to point to the ingress, and since we deleted the ingress file, it is not working as expected. So let's go under the templates and under the TechTalk, let's go and delete that nodes.txt. I don't really need that right now. And since we deleted this, we have to repackage the application. Once the packaging is done, let's go and install. With the package generated, let's go and see what happens when we try to install the package. Now the installation fails, saying RabbitMQ consumer deployment already exists. And this is because in our TechTalks consumer deployment, we have multiple YAML files. So let's go and delete the ones which are not required and keep only the one which is a working copy. And let's go and package the application again and then install it. So now we get an error saying the Helm install TechTalks failed because we have a release, or we did a partial installation. It failed after installing some of the components. So we need to do the uninstall. This can be done easily using helm uninstall command, and we give the name of the release here. To overcome this problem, we need to go and uninstall the package or the release, and the release named is TechTalk. So when we run helm uninstall TechTalk command, it will uninstall the release and then we can do the installation again. So we do helm install and then say TechTalk and give the name or the package path. And now we have the TechTalk deployed. With the application installed using Helm, let's go into the Lens UI and see what are the different objects that has been installed. So when we head over to the Helm section and look at the releases, we see TechTalk has been deployed just about 36 seconds ago with the app version as 1.1.0 and the chart version as 0.1.0. And if we go into the services section, we should find a service for RabbitMQ producer service, which is running on port 8080. And same way, under the deployments, we should find the deployments for TechTalks producer or RabbitMQ producer and RabbitMQ consumer. So all this is running, or all this is deployed using Helm with the default values or whatever values were initially same as our before. But instead of running kubectl apply command separately or kubectl apply recursively, we have been able to do it using the Helm apply command or Helm install command. Is that the benefit? Or is that the only benefit of using Helm? Obviously not. As we saw in those templated versions or earlier when the generated code was there, we could use the templating engine of Helm. So let's start by looking at how we can use the capabilities of Helm in our producer service to start with. Now, if you look at the definition of the service, there are sections which can change across the environment, and there are things which are common between different sections of this particular manifest file. Starting with the type of the service. Currently, this is running as a cluster IP service, but we can also deploy this and access it outside the Kubernetes cluster using the load balancer type of service. Then we have the ports, the port which is specified at the service level, and the target port which is targeting the container where the service is selecting this particular container. And we also have the selector. So using the values.yaml file, we can provide an option for the users to override these values. We can provide a default values in the first place, and then the user can override them when they deploy it to different environments. So let's look at this capability and see how we want to do that. Let's start by creating a property in the values.yaml and name it as TechTalks Producer. And in this, we want the number of replicas. So if we look at the deployment, it has replicas as 3. And for the service, we have the service type. So maybe let's start with the service first. And for the service, we have the type as cluster IP, port as 8080, and target port as 8080 as well. Once we have specified these values in the values.yaml, how do we use them in our producer service? This is done using the variable kind of replacement or using the templates. We start with these curly braces and then use .values to indicate that we are using the values file here. TechTalks Producer is the key which has the service key inside that. So .service, and then we have 3 different subtypes or subproperties there. I'm going to specify type for the type value, and same way when it comes to the port and the container port, I can just replace this with the port value, and for the container port it would be the container port. Or it's the target port. All these values, 3 values, are part of the service key. So we are specifying those 3 here, and the same port value is being used by Dapr here for the annotation. So we can replace that hard-coded 8080 value with the placeholder. Now when we apply this configuration and when we run the Helm install using the values.yaml file, these values, they get replaced, and at the runtime also we can override. So let's try this out. First thing we have to do is to package the application again, because we have changed the values. So let's start with Helm package, and then we give the TechTalks as the directory name, and we have successfully created the new version of this TechTalks application. Now let's go and deploy this Helm. First we need to uninstall the TechTalk from our Kubernetes cluster, and then we will install again. Helm install TechTalk is the name of the release, and then we specify the package, and now we are going to verify that this particular thing works. So this is the RabbitMQ user interface, which allows us to see the number of messages and how they are being processed. And in the Lens UI, when we go into the services section, we would be able to do a port forwarding to our RabbitMQ producer service, which gives us the option to generate a number of messages. Now, in my past experience, I know that this needs to be stopped, the port forwarding, and it needs to be started again. So I'm going to restart it, and in here we have the generate method with the number of messages to be generated. So let's start with simple 1000 messages. And in our RabbitMQ UI, we should see a spike in the messages here. And the producer output says that the successfully produced 1000 messages. And in the RabbitMQ UI, we can see 1000 messages have been produced, which means that the replacement of the values that we did has been applied successfully to our producer deployment. Now let's go and enhance this a little bit further. Those were the things we did for service. Let's go and do the same thing for deployment as well. If we look at the deployment definition, we find some things like labels which are repeated, and they are almost common across all the places. Metadata for the deployment has labels section. The specification for the selector has a match labels, which is similar to the label metadata or deployment metadata. And then the template also has the labels, which is exactly same as the deployment. So we can reuse this feature of Helm, or we can create a label in Helm and then apply that consistently across all the levels. To do that, we need to define these labels. So let me just copy these two values. The run label, which is a key value pair, actually run as the key and value as RabbitMQ producer, and same way there is the app key with TechTalks as the value. And let's go to values.yaml, and under the TechTalks producer, let's put a top level key as labels. And the GitHub Copilot is giving me recommendation that I should put run and the app as the labels for that. I will go ahead and use that recommendation. Now to use these labels in our deployment or in our service or any other Kubernetes manifest file, we can go to the template and create a helper function. Under the helpers, we see that there are already some sections which are created or some helper methods which are created, and I'm going to add one for the producer labels. To save time, let me just pick something from my earlier test, and I'm going to copy and paste it here, both for the producer and consumer, because we are going to do the same thing for the consumers as well. And I'm going to explain what we are doing here. So if we look at the producer part, we have this definition for the TechTalks producer label where we are fetching the values but with a with construct. So this is like a loop in Helm or Helm templates. We are using values that are defined under the TechTalks producer and the labels section, and then we use this range with key and value. We iterate over all the keys and values, and we put a quote around the values part. So basically it's taking whatever we defined in the labels and it's rendering with a quoted string here. Now to use this, I can go into the producer service and wherever I want to replace. So let's start with the deployment, because there we have 3 different levels of labels. So here I can replace this with an include statement, and again the GitHub Copilot is giving me auto-generated code here. We say include and we see the indentation given here, because if you worked with YAML files, it works very specifically with the number of indents or number of spaces. Even if we miss one space here and there, it will cause problems. So the labels in this case at the deployment level are 4 spaces indented. That's why we have the indent at 4. We have to be careful with what we use as the include name. Since we want the labels which are named as TechTalks producer label, that is what we are going to put inside here, and this will be indented to the 4 spaces. Same way we are going to replace this label or the match label. This is similar to the earlier label, but the difference here is this has to be indented 6 spaces because we have additional 2 indents there, And finally, within the template for the container also, we have the labels which we are going to replace, and the indent is going to be 8 there. Then we go and do the same thing for the service, which has this run label or label defined here. Let's go and use the same labels, and even at the selector level we do the same. And in here, both the places, the indent is 4 itself. Now let's go and again regenerate the chart. Let's first uninstall, then do the packaging of the chart, and then let's go and install it. So here we have gone and deployed the producer with the labels which are replaced using the template feature. Let's go again into the lens and see how does this work. So first we need to go and stop the port forwarding and then forward it again, and then use the generate method to generate certain number of messages, let's say 5000 this time. And if we see the spike here, that means the labels have been effectively picked up and we are now able to reuse the labels. So Helm is intelligent enough to apply those labels using this template feature. So this we can verify by looking at things like the details of the Kubernetes object. Let's go into the deployments and let's look at the producer deployment. In the labels, we can see here that it has applied app as TechTalks, run as RabbitMQ producer, and then there is a default label app.kubernetes.io managed by Helm. This is added automatically by Helm, but the other two labels is what we specified for the RabbitMQ producer deployment. Now if I go back and we look at the producer deployment here, we see that all these labels, the specification for the selector as well as the label for the pods, all are coming from the template. So if I go back into the pod section and we look at the RabbitMQ producer pod, that will also have the same label. So let's pull one of those here, RabbitMQ producer deployment, and these are the pods, and there again under the labels we can see app TechTalks and the run RabbitMQ producer have been applied by that template. Let's switch back to the template engine again, and now the thing we are going to do is to replace the image and the tag. So this process is pretty straightforward. And in the values, we can define, similar to the labels and the service tag or service keys, we can define a key for the image, and we can say repository. This one is Nilesh Gule, then TechTalks producer, and the tag is go. Now to use this, it's a simple thing like we did earlier for the service. We go and replace these values using the placeholder. So two curly braces dot values dot TechTalks producer is what we have. Then there is the image tag, and that has the repository, and then if we specify the tag here, we'll have dot values dot TechTalks producer dot image and dot tag. We also have the container port here. So like the service, we can define the container port directly and specify container port as 8080 and use that to replace the value. And the same container port is used at the app port level above, so I'm going to replace this hard-coded 8080 with the value from values.yaml. And this replica, let's also replace that with the value which is coming from values.yaml file. So we define a key as replicas, and we take this from .values TechTalks producer .replicas. And with that, we have replaced most of the values which are like parameters or which can be parameterized. Let's go and rerun again. Before that, let's look at the service ones. Okay, let's replace the labels in the service so that it is consistent with our deployment. And we do the same thing for the selector as well. And the app port, we can take the value from port number here. Then we start by uninstalling the application, then package it, and then install. So the application has been deployed with all the changes that we made to the producer service and the deployment. Let's go verify once again quickly. So under the services, let's go and recreate the port mapping for producer service on port number 8080. Start it. Let's head over to the service, RabbitMQ producer service, and hit the generate endpoint and see what happens in this case. Let's generate 10,000 messages this time. And in our RabbitMQ UI, again, we should see a spike in the number of messages. And there we have it. So with this change, we are now still able to produce messages by using the template feature of Helm and the template engine provided along with the values.yaml. I can do the same thing for the consumer as well, where we have these different things like the labels, the number of replicas, the selector, and the image and the tag name along with the container port. Instead of doing it one by one, let me fast forward and come back to it. So here I have created the sections for TechTalks Consumer in the values.yaml. We have the labels similar to the producer labels, where the run label has RabbitMQ Consumer or RabbitMQ-Consumer as the value. App has the TechTalks value. In the image, we use Nilesh Gule TechTalks Consumer and tag is Go. Container port is 8081. And then we use this information in the consumer deployment -go.yaml file. We can rename that to consumer deployment.yaml now. And then if we look at how these are used, these are similar to the labels from the producer section with indent 4 at the deployment level, and then at the template level we have the label applied at the indent 8. We can also apply it at this match label, but then we don't have a service exposing our TechTalks Consumer, so this particular match label doesn't really make any sense here. We can just delete it. Replicas is hard coded to 1 because this is managed through the KEDA autoscaler. So again, specifying replicas here doesn't make a huge difference, so I've kept it as hard coded as 1 for time being. And then we have this things coming from values.yaml, the TechTalks image and the tag, as well as the container port, and we can use this same port variable on the app port annotation for Dapr. And with that, let me go back, regenerate first, stop or uninstall the application, then package the TechTalks chart, and finally go and install this. So now we have the TechTalks whole application deployed again, and both our producer, in terms of the producer deployment, producer service is using the Helm template engine, as well as the consumer deployment, which is only one manifest file, that is also using the template feature of the Helm. And we have templatized as much as possible all the components like the labels, the port, the image name, and the tag, all these things. So with that, I have come to the end of this demo. We saw how to use Helm to package the TechTalks application consisting of 2 different services along with its dependencies like the autoscale configuration as well as the Dapr configuration. Now, if I look at the autoscale consumer configuration and the Dapr configuration, it has things which are pretty static. If we want, we can make this dynamic, and I would leave it to the viewers as a homework or your hands-on exercise to templatize this. If you do convert this into a template, feel free to raise a pull request, and I'll be very happy to integrate that into the main source code for Cloud Native Ninja series. Since most of this is static, I haven't spent much time to parameterize this, but you can definitely give it a try, and I'm pretty sure it will work with the Helm. Now, when it came to the Helm itself, it was very simple to create the Helm chart and to use the Helm create command to get started, to have a predefined or scaffolded values for different things. But we didn't have the exact same structure as the default Helm template, so we used our own folder structure for the TechTalks producer and consumer, and then we use the template switcher to put all our manifest file inside the template. We also use the helper template to create the producer and consumer labels and to replace those labels in our manifest file, and in other places we use a straightforward replacement of the values from values.yaml. Now, one thing which we can do here is to use to override the values by setting the values. So we can set like TechTalks producer, and the TechTalks producer has the image inside that, and image has a tag. We can use a tag of, instead of Go, I can say Java, or I can use .NET. That is how on the command line we can override the values which are still part of values.yaml, and probably we can look at those advanced feature in a separate YouTube video. And once we have this package created using the Helm package, we can install the package using Helm install, and we also looked at how to uninstall using the Helm uninstall package. And with those 2 commands, install and uninstall, all the components of the application, they get installed correctly and they also get uninstalled. So we don't have to specifically go and run kubectl apply commands specifically on different folders. That is the benefit of using a package manager like Helm, which gives us the ability to upgrade and as well as roll back versions of the application which is deployed to Kubernetes. So with that, we come to the end of this video. I hope you found this useful. Please hit the like button in case the video was useful to you, and subscribe to my channel for future updates. Hit that bell icon to get notification when new videos are published. And in the comment section, do let me know what other things you would like me to cover as part of the Cloud Native Ninja series or other videos on this channel. Also, if there are better ways of doing things that I have shown here, please feel free to specify that in the comments. Until next time, code with passion and strive for excellence. Thanks for watching this once again.